Hello everyone, welcome to Geeks for Geeks. Myself Shivam, and today we are going to do problem of the day. The problem name is multiply two linked list. So first, we will go through the problem statement. We will see some of the test cases, and then we will try to discuss the time and space complexity. We will be also writing code together in Python. So let's start. So what is the problem statement we have here? So given two elements as node of the two singly linked list, our task is to multiply this two linked list. So it means we are given with two linked lists and we need to multiply both the linked lists and we need to return the output in modulo 10 to the power 9 plus 7. So let's see the test cases to understand it better. So if you see the test case 1, in the first test case, we have two linked lists. Linked list 1 is 3 and 2, whereas linked list 2 is 2. Now, if I'm giving you two numbers, let's say 32 and 2, and if I'm asking you to multiply them, what you are going to do? That's going to be very simple, right? You are going to multiply this n1 with n2, and it will be 64. So the same thing is happening here. Just I have given you the numbers in the input. It is given in the form of linked list. So the output is going to be 64 here. Now talking about test case 2 as well. If you see, we are given with two linked lists, and on multiplying both the linked list, our number is going to be 1000. And the best part is that we have to return the output in the form of number only. So 100 into 10 is going to be 1000 only, right? So I hope the test cases are very clear to you. Now let's discuss the approach. I have divided the approach into three steps. So we understood from the problem statement and from the test cases that if we are given with two linked lists, if somehow we can convert both the linked list into number, then we are going to just multiply them and we are going to return it. So it's going to be very easy for us, right? So this is the first step we have. We need to just convert the given linked list into number. And if we could do that, then the second step is to multiply both the numbers. And the third step is to return the result, but don't forget to use modulo 10 to the power 9 plus 7. Because it might happen then that our outputs which we are getting is computed is very large. So we don't want it to cross the range of integer. And that is the reason we are using 10 to the power 9 plus 7. Now let's discuss this with the help of one more example. So if you are given with linked list, the first step is to convert the linked list into number. So how we are going to do this? Let's try to understand this. So the first time we are coming to this linked list, let's say we are traversing on this linked list and we are on node 3. So let's say our number is 3 now. Now we traverse to the next node of the linked list. So now we are on 4. On coming to 4, we need to do some calculations so that our number becomes 34. It means the current number is 3. We need to make it 34. How we are going to do this? I hope you are able to find out. So we just have to multiply our number with 10 and we need to add current node in our number, that is 4, and we will get our number, that is 34. So now our number is 34. That we have achieved our number, which is 34 now. Now let's traverse in the next node. So the next node is 2. It means now we need to include this 2 in our number as well. So our number should now become 342. Now how we are going to do this? So for that, again, we are going to do the same thing that we did before. We are going to just multiply our number with 10 and we are going to add the number which we want to add, which is 2. So our number will become 342. So from this, I hope you are able to understand the formula behind it. So we can say whatever the current number we have, we just need to multiply it with 10 and we need to add with current node data. And using this formula, we can get our number, right? So let's color it in red. So this is the formula which we are not going to only use for linked list 1. We are going to use it on linked list 2 as well to find the number. So from the step 1 was to convert the given linked list into numbers. Now through this we can achieve it. Now the step 2 was that we have converted the linked list into number. We just need to multiply them. So I hope you will able to follow this. So the linked list 1 is now converted into a simple number. Let's say n1, which is equal to 342. And if we apply the same thing, then linked list 2, we can also convert it into a number which will become 46. Now after that, you just need to multiply n1 and n2 and you will get your number, which is going to be your output, right? And don't forget the step 3, which was to return the number with modulo 10 to the power 9 plus 7. So I hope you understood the whole approach. Now let's try to see the code. So in this code, I will also try to show you the use of modulo, how important the use of modulo here. Okay, so let's try to first write down the code, and then we will try to understand the other things. So first of all, what I'm going to do, as we decided our step 1, that we have two linked lists, we are going to have two numbers as well, and we are going to convert them into simple number, right? So let's say we have num1, num2 is equal to 0. So both the numbers are starting from 0. Now we are going to have our mod as well. Let's say our mod is already given, which should be 10 to the power 9 plus 7. So let's have it before 6, 7, 8, 8 zeros, and then added 7 into it. So it has become this number. Now we need to traverse, right? So we are using while loop here. So we are writing that if first or second node become none, if both of them become none, it means or null, then we have to come out from the while loop, right? So if first or second is null, if then we are only going to come out from the while loop. Otherwise, we will execute the code written inside the while loop. So let's write down. The first, I'm checking if first is not null, right? If first is not null, then I have to go inside it and I have to use our formula that we have discussed in the last slide, right? So I will be using the same, and I will be saying that our num1 is equal to num1 multiplied 10 plus the current node at which we are, right? So let's say we are on node first dot data, and that's it. I'm not making use of mod here, just to show you that how our output will be. Now similarly, I have to do the same with, and also after calculating we have to go forward, right? So that we have to write, so first equal to first dot next. We have to do same with the second node we have. This time it's going to be num2 second dot data, and just we have to do the same with second node. Now from this we are done with the first step, which was to convert the linked list into number. Now since we have converted, we should come out from the while loop and we should just return our output. Also, I have already mentioned in the third step we are going to use modulo. So let's use modulo the number we have, the variable we have taken, which was mod in the line number 17, if you can see. So now let's try to execute it and let's try to see in action. Okay, sorry, my bad. I have written minus here. It should be equal to. Now let's compile and see. Yeah, so it is working as expected, but let's try to submit and let's try to see if it is passing all the test cases. If you see, this failed with TLE, which was as expected. Why? The thing is that our number has already grown so large that it gave you TLE and it is taking too much time to compute. So we need to make our number smaller so that it doesn't passes the range of our integer, or it doesn't take so much time. So what we can do, you just have to put modulo here itself. It means whenever you will be converting linked list 1 to number, you will make sure that the number is not very large. So that's why I will be using mod here. As well as for the second number, I am going to do the same thing. So now if I try to compile it and let's try to see. So at least it is passing some of the cases, but let's try to submit and let's see this time, is it giving us TLE or not? So this time you can see it passed all the test cases because we have used modulo. So this is very important use of modulo we can understand from this. Now let's try to understand the time and space complexity we have. Now, talking about the time and space complexity we have. So while traversing the first linked list, if the length of the linked list 1 is n, then our time complexity is going to be big of n because we are traversing the whole linked list. Now, if the length of the second linked list is m, then the time complexity is going to be big O of n. Now, if we are multiplying two numbers, then it would take no time because we know this. Like if we are adding, subtracting, multiplying, or dividing, then it takes no time and it is constant, right? So it's big of 1 only. So the overall time complexity is big of n plus m. Okay. And talking about the space complexity, since we are traversing in the first list and we are just storing the result in a simple number, right? In a simple integer. So it is not going to take much space and it would be big of 1 only. That would be constant space. Same with the second linked list. We are just using one more integer and then we are multiplying it and then we are returning it. So we are not storing anything here. So again, the space complexity would be big of 1. So the overall space complexity is going to be big of 1 here. So total space complexity is also big of 1. Now let's see, what was it expected in the question as well. So if you see in the question, it is the expected time complexity is big O of max n and m. So the problem is that our time complexity is big O of n plus m. But the code that we have written has time complexity of big O of max n plus m only. Look, let's try to understand the difference. I'm going to give you a very simple example. If you are going to traverse in the first linked list using a one while loop or for loop, whatever loop you are using, then it will require n time. Now you will have a separate while loop and you will traverse in the second linked list. Then it will again take or it will again execute that while loop for m times. So the time complexity is getting added here. But in our code, we are not doing so. We have used only one for loop or while loop. In our case, we have used while loop and we are traversing it, right? And we will come out once both of the number is false or null. So it means our time complexity is depending on the maximum size of linked list. If linked list 1 is of size 5 and linked list 2 is of size 10, then what do you think? When we will be coming out from the while loop? We will be coming out from the while loop when this second length is fulfilled. It means when we have already traversed 10 nodes, right? So the while loop will be executing only 10 times. It means our while loop is depending on the linked list which is of maximum size. And that is the reason our time complexity is going to be max of n and m. By the way, there is no much difference in both the time complexity. So even if you are going to use two while loops, it should not give you TLE. I hope you're able to understand this. Now, I hope you will able to write code by yourself now. Thank you.